Let's solve this quadratic by sketching two graphs. So here we are on Desmos, and here is the first graph, y equals x squared. And here is the second graph, y equals 2x plus 8. It's a straight line. And the quadratic intersects at x equals -2 and 4. So you can see that we're solving the x value, which is -2 and 4, not the y value. The y value here would be 4 and 16. Now let's sketch one graph only. So the first way, we thought of it as y equals this and y equals this. But what we could do is combine this into one single function by throwing things over algebraically. So throwing these terms over, we get x squared minus 2x minus 8 equals 0. So now if you think of this as our y value, y is equals to x squared minus 2x minus 8. When y is 0, essentially we're finding the x-intercepts. We're solving the possible values of x. So this here, by using algebra, we can treat this and solve x using a single function, and this would be our single function. So here is our quadratic. We just punch this into Desmos, y equals x squared minus 2x minus 8. And you can see that we have the same answers, x equals 4 and x equals -2. Now I think the easiest way to solve this problem is algebraically. So we're just going to continue off our work up here. It's good to throw things over and set y equals 0, because that's what solving means. You're finding the x-intercepts, which means you're setting y equals 0. And we're going to factor. So we're going to try to factor something equals 0. We have x. What times what is -8 but adds to be -2? Let's try -4 and plus 2. And you can verify it. They multiply to be -8, but they add to be -2. This is right. Something times something equals 0, so therefore x minus 4 equals 0. Or x plus 2, this factor, equals 0. You can throw the numbers over, and we get the solutions. We solve x as 4 or x equals -2. So two possible answers. So going back, we can see that indeed there are two answers. X equals 4, x equals -2, and there's no extraneous roots. Okay, so you can see that we have two equations, and indeed there are two solutions. There are no extraneous solutions. And for the sake of practice, we can take one of these roots, one of these answers, and plug it back in to the original equation. For example, the left side here. When x equals 4, the y value, y equals x squared, would equal 4 squared, which is 16. So for finding the actual coordinates, the xy coordinates of the point of intersection, this would be one coordinate, or one set of coordinates. The xy coordinates would be 4, 16. Similarly, when you substitute x equals -2, when x equals -2, y equals x squared, y equals -2 squared, y equals 4, -2, 4 would be the other coordinates. So it would be the other point. You can plug it into either this equation, or you can even plug it into this equation here. And now it's your turn.